So the pH scale and the pOH scale are essentially opposites of each other. pH measures the power of hydrogen, and acids tend to have a lot of hydrogen ions. So on the pH scale, an acid will have a pH of 0 to 7. But since bases do not have a lot of H ions, they have a lot of hydroxide ions. That puts them in the range of 7 to 14. So acids have a high concentration of H+, but they have a low concentration of OH-. So that's why if we look at the pOH scale, it's going to be the exact opposite of that. Since this measures the concentration of OH, that puts bases having the pOH of 0 to 7 because it's a very high concentration of OH, whereas acids don't have a lot of OH, they have a lot of H, which puts them at a higher pOH. So if an acid has a low pH, it's going to have a high pOH. And if a base has a high pH, it's going to have a low pOH. So that leads us to this formula. The pH plus the pOH should always equal 14. If a substance has a pH of 3, what is its pOH? We can use the formula to figure this out. If we have a pH of 3, we know that 3 plus the pOH has to equal 14. So that puts our pOH at 11. If a substance has a pOH of 6.5, what would be its pH? Well, we know that the pH plus the 6.5 has to equal 14. We may not know off the top of our head what plus 6.5 gives us 14, so we can just subtract 6.5 from both sides. So we get that our pH is 7.5. This other formula doesn't look at the pH and the pOH, but it does look at the actual concentrations of our ions. So anytime you see these bracket symbols, you need to know that that means concentration. So looking at this formula, the H plus inside of these brackets is actually telling us that that is the concentration of H plus. And the concentration of H plus is being multiplied by, again, we have these brackets. So this is going to be the concentration of OH minus. So anytime you have the concentration of H plus and the concentration of OH minus, if you multiply those things, it will always equal this number. So let's look at this question. If the concentration of H plus is 2.5 times 10 to the negative third molar, what would be the concentration of OH minus? So since the question says the concentration of H plus, that's the same thing as putting that in brackets. So we're basically saying that that concentration of H plus in those brackets is 2.5 times 10 to the negative third. And the question asks, what would be the concentration of OH minus? So again, concentration of just means brackets. So that is the value that we're looking for. That's going to be our X. And just like any other time we have a formula, we are going to plug those numbers in. So for concentration of H plus, we have 2.5 times 10 to the negative third. For our concentration of OH minus, that is what we're solving for, so that's going to be X. And all of that is equal to 1 times 10 to the negative 14th. As always, our goal is to get X by itself, so we're going to divide by that number on both sides. And now all we need to do is type this into our calculator. Remember, when we're using scientific notation, we want to always make sure that that whole number is going to be in parentheses. So here we go. Parentheses, 1 times 10 to the negative 14th divided by 2.5 times 10 to the negative third. Close my parentheses, and that is going to be my answer. And again, we're talking about concentration, which the units will always be molar for concentration.